this so far. You're feeling better. Okay. Sorry, drinking coffee today. He's really like coffee.
Feel better, kid.
Yeah. All right, Luca, we finished our table down here. We were trying to find the maximum, and so we filled into our nifty-difty little table the vertices that we found from our graph. We plugged into our objective, and then, guys, how did we choose this one? It's the biggest, and we were trying to find the maximum. So we filled in our little answer of the highest it can be, it, meaning the objective, is 8, and where it happens, or when it happens, is 2, 1. We looked at the book telling us, sorry, that's just the book solving it. We looked at the book telling us another way of looking at things where we can solve the objective for y. We can think about it as lots of lines with the exact same slope but different y-intercepts because z can change. And then we were asking, hey, what's the furthest that these lines can go and still hit the shading? And it's when z is 8. Which is when it hits the curve at 2, 1, and that's the answer that we found. But no big dealio. The math works. This is how we're going to be solving. This is what you're responsible for. The other one is just a representation. Okay.
Just right down there.
What's going on here?
Good question.
Now, you don't have to write down all the words necessarily, but here is a warning, okay? Down here at the very, 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 very bottom, it says, some linear programming problems have no optimal solution. What? Some linear programming problems have no optimal solutions. That's one unusual thing that can occur when we're solving. At the very top, it is possible for the max or min to occur at 2 or more different vertices. 2 or more? We did the graphical illustration just to be able to show you guys why. We have right here, someone has done all the work for us of figuring out the overlap shaded part, okay? The vertices, as you guys can tell, are the corners. So we have a vertex there, sorry, vertex. Vertex is singular, vertices is plural. Alumnus, alumni. Sheep and shoot, just kidding. Sheep and sheep, that one's boring. Goose and geese. Potatoes and potatoes. No, moose is singular. It's moose and moose.
Yeah. Why isn't it so we have geese? Why isn't it moose and geese?
English is such an adventure all the time. Okay, so.
Yeah, now I understand why
Right?
Four people.
And then we have there and there. Actually, there and there and there.
And
Right?
2 and 2. 2 and 2.
There.
Yeah.
2.
Oh,
Oh yeah! Oh, my thing was. There's 3 2s. 2 with a W, 2 with an L, 2 with 2 O's.
Okay. Okay, wait, pause. Going back to something that's mathematical and useful. In this class, there are things that are useful in, say, your essays that you're supposed to be writing in many different classes using correct spelling and grammar and showing advanced thought. And not plagiarism. So, if we were to solve for y, we would subtract 2x and we divide everybody by 2. We would get negative x plus z over 2, right? Oops, that z looks like a 2. Anyway, we have our shading. If we were to think about the whole graphing thingamabob that we did just a second ago, what lines would have a slope of negative 1? Well, wouldn't it go through 1 and 1? Right? Go down 1 over 1. And then down 2 over 2, and then down 3 over 3. So our lines would look like oh, stink. Kiddos, what's the furthest that line can go? We have when z equals 6, right? But doesn't it hit that whole way?
Yeah.
If it hits that whole way, how many different solutions are there?
Infinite within that constraint.
Stink. How would we know there are infinitely many within that constraint? What vertices would we be testing? They already started testing. How would we finish testing? They tested 0, 0. They tested 0, 4. What other vertices do we have?
2, 4.
2, 4, 5, 0, 5, 1. Okay. Let's try real quick. 5, 0, just to prove a point. Z is equal to, let's skip all the math, plugging it in. 5 is 10, okay, equal 10. Then let's test at, so let's see, we've gotten that one, we've gotten that one, we've gotten that one. We have 2 more. At 2, 4, if we're doing the math, we want to see what's going on at these 2 points. Z equals at 2, 4 after showing work. Z equals at 2, 4 after showing work. Sorry, at 5, 1. You guys get 12?
Yeah.
Oh, sorry, Z over 2 equals 6. That's my bad. I wrote Z equals 6, but it's Z over 2 equals 6. Struggle. So then Z equals 12. Anyway, long story short. Do you see how these guys tie?
Yeah.
How do they tie? Because they show the beginning and the end of all of these solutions that hit on the line. You guys see it? So whenever you're doing your testing by plugging your vertices into your table, because who wants to be like drawing all these spiffy-diffy lines? Probably not many of you. When you get a tie, we are going to say that there's going to be a maximum value of what? 12. A maximum of 12 at 2, 4 and 5, 1. Now, we're answering this way because they told us the maximum is always going to occur at a vertex. And is that true in this case? You might say no, but the answer is yes. Is 12 occurring at a vertex? Yeah. Is 12 occurring at 2 vertices? Sorry, it hits at 6. But 6 here, oops, 6 here. There's also 6 here, which is the z or the y-intercept. Sorry, not the z. The y-intercept, and the y-intercept is z over 2. So from the 6, z is actually 12. Is that what I'm saying? I didn't set it equal to z over 2. That was my bad. The question is, in this case, guys, does it happen at more places than just the vertices? Yeah. But did we technically find the vertices that have the maximum value of 12? Yeah. So we're okay. We're okay. We don't need to state all the infinitely many points. We're just trying to basically say, hey, we used our vertices. We figured out which ones helped us find the max, and we found the max. It's 12. So to be honest, the point is probably finding the 12. We just use the vertices to get there, but we're also stating which vertices we found to equal that, okay? However, at the very, very bottom of the page is actually saying, okay, not only could you have more than one vertex tie and have the same max, which we're fine, we found the max, it's 12. That's kind of like the first weird thing that can happen. There's a second weird thing that can happen. Some have no optimal solutions, meaning no maximum. And let me show you a quick example of what that would look like. We could even use the exact same objective function. We can even use z equals 2x plus 2y. But let's say all the work was done for you for shading. And let's say you got the following. There we go. Stink. Yeah. is this a problem?
Because they're both extending into a region by which we have no means of end.
Ooh, no means of an end, what does that mean? What are my lines gonna keep doing as I go? That be one, that be one, that be two, either way. My lines are gonna be able to keep on going forever. So is there a maximum? No. Wait, how do we kind of know that based on what they told us? If it's not bounded, isn't it gonna keep on going forever? Yes. Now, in this one, will there still be a minimum? And the answer is yes, because there's a lowest, but there's not a highest. In other ones, you might have a highest, but not a lowest. Just depends. It's not super realistic. It's not super realistic. There aren't many things in life that are unbounded. There are a lot of spiritual things that are unbounded. Souls are unbounded. God is unbounded. Evil is unbounded because Satan is technically an infinite being as well. Being, he was created. Space, according to string theorists, they would say seems unbounded. They might even say it's unbounded. However, if space was created, truly infinite. Well, I guess our souls are infinite. They were created, so maybe it could be. But God's a greater infinity. What? There are greater, varying degrees of infinity, and the answer is yes. That's an application, or I should say, that's a conversation for another day. Oh no! Ella, what was your comment?
So, when there's a maximum, it has to be a closed shade.
Has to be a closed shade on the maximum side, but it could be unbounded on the negative side. So if we're looking for a maximum, we don't care what's going on the other way. Does that make sense? Or if we're looking for a minimum, we don't care what's going on the other way. So it could be unbounded maximum. Question. How terrifying does this look?
I don't know, chocolates.
However, do we have to write all the words?
No.
Oh, so all we gotta do is figure out the math? Okay.
A profit is $1.50 per month.
Hey, it's chocolate. We just had Valentine's Day. It's applicable, right? Okay, so here we go.
Well, the chocolate's on sale today, guys.
What? Go to Walmart.
The damn
Stuff is on sale today.
Question. How do I know that I'm supposed to be doing this whole plugging into a table and testing? Who's the objective?
The combined profit. There are 2 types of box chocolate.
Right? First of all, I see maximize. Then I need to know, or I know I need to find the vertex that maximizes our quantity. What quantity? The combined profit. So my question to you is, what are we, because we're supposed to be translating this into math, what are we going to be calling our objective function? Okay, we're going to be calling it profit. Sorry, that's silly. What equation is the objective function?
P.
Oh, wait,
We got to make
Like
some
P.
variables.
Let's
Okay.
just- yeah.
So who are we making who?
profit.
Profit. Profit and total.
Profit is
P
E. Okay, so P instead of Z equals profit equals what?
Well, there's 2 different boxes.
There's 2 different types of boxes. The one
So 150 times C, because that's pure chocolate, and then 2 times N, because it's nuts.
So the creams and then the nuts? Okay. I can do that. If you guys want to label, P is profit, C is chocolate creams, and N is chocolate covered nuts. Macadamia ones. So wait, we have our objective, right? Now what do we do with him? We sit on him. We wait. We wait? Yeah. Don't we wait to plug into him at the very, very end? Okay. But you guys didn't have to write the paragraph, but you did have to identify the objective. Did you write him down?
Yes.
Good. Now what do we need to do? Market tests and available resources have indicated the following constraints.
Easier constraints.
Alright, let's go try to translate into math our constraints. The combined production level should not exceed 1,200 boxes per month. They could be limited by man hours, they could be limited by time, they could be limited by resources like energy costs, keeping the machinery running, etc., who knows? But for some reason, the combined production level should not exceed 1,200 boxes per month. So, how do we make that a mathematical expression?
Less than or equal to.
Is that both boxes or one specific type? Oh, okay. So we have the creams and need to be. Does that make sense?
Yes.
How many of the C's we make and how many of the N's we make? How many boxes of one? How many boxes of the other? Maybe they figured out they start losing money if they try to produce any more than that. I don't know. Okay, number 2, the demand for a box of chocolate covered nuts is no more than, all these inequality words. Half the demand for a box of chocolate covered beans is no more than half. So, don't we in math usually just try to match it up? So demand for that's N, right?
Yeah.
Is no more than, what is no more than? Less than or equal to, or just less than?
I think less than equal to.
Yeah, can't be more than, but it could be equal to, I suppose. Just like number 1 should not exceed, but they didn't say it couldn't equal. Half the demand, half times, right? Box of chocolate covered things. Got it. Good job, guys. If you guys don't like C's and N's, yes, of course, you could be using X's and Y's. Number 3. What's our third constraint? Okay, so who's that?
C.
C. Should be,
Less
oh,
than-
look at
Wow,
them.
they're so nice.
600 plus
3 times.
Mm,
Yeah. Okay. Now, here's the trick. There are actually 2 more constraints they didn't even tell us, but we should know.
positive.
First quadrant, how come?
You can't have any negative production, you can't have negative
Yeah,
demand.
you don't want to produce a negative amount. That's just trouble, right? I guess negative amount the employees are taking home. Either way. Right? We probably don't even want them equal to 0, to be honest, but we'll just say greater than or equal to 0. Quadrant 1. Okay, what are they asking us for at the very bottom? What is the... Okay, so we want the maximum value of the profit. I think we already do that, don't we? Maximum Z of at. How many boxes of... Okay, they want the at, they want the of, they want the of, and they want the at. No big deal. So, kiddos, what's our job? Oh, how do we tackle? We have all the pieces.
Sketch.
We can't plug it in until we sketch. Remember our 3 steps. Sketch it. Find the vertices, plug it in, plug it in. Find the one that wins. How do we sketch? Brandon's asking a very good question. What's going to be the X and what's going to be the Y?
CNN.
Do we have to choose that to graph? Yeah. So let's go ahead and, if you guys want, even though it's super spiffy in the sense of you guys trying to make it all nice and, particular to the name, maybe we should just do X and Y. So making the chocolate covered creams X, making the chocolate covered nuts Y. Okay? So we have, everywhere there's a C, we need to make it X. Just so we're on the same page. Everywhere there's an N, we should make it Y. Bummer. Maybe we should have done it the other way. Oh well. Now we've got to take all of our clues and copy them down. So, we have X greater than or equal to 0. We have Y greater than or equal to 0. What's another one that we have, guys?
X plus Y is less than
Hey, can we solve for Y?
equal.
Make it y less than or equal to 1200 minus x. Is that cool? Yeah, I can make it negative x plus 1200 if you like that better. What else do we have? Oh, y less than or equal to 1/2 x. We can do that. What else do we have? Ew, solve for y. X minus 600 divided by 3. Is it greater than? Yeah. Is it 1/2 x, right?
Wait, just make sure what happened. What's the difference between a 1/2 x and a 1/2 x?
Ah, because they're from two different clues.
Okay.
So I have this guy was the first clue.
Oh, okay.
And then subtracting. Oh, I divide by 3. I was dividing by 2. Those the answer. I remembered wrong. Dividing by 3. So that'd be 1/3 x minus 200. Is that better? Now what do we gotta do with that guy? Okay. Why am I mostly gonna have first quadrant? Yeah. Because I can't have negative boxes of any of these guys. Just hopefully I don't have negative demand. That would be scary. Can't we automatically just cancel out the first two and say, oh, no big deal, first quadrant, we got this? Okay. First quadrant, we got this. What units would you guys be going by if you're going by 200 and 1200? Yeah, let's do that. So we'll go 2, 4, 6, 8, 10, 12. Sound good? And negative 200? Okay. Color coding, let's go. We got this guy. I'm gonna put some tick marks over here too. Positive 1200. Got it. Go down 1/1. Ew, what? Wait, can't I go down 1 tick mark over 1 tick mark as long as I am still maintaining my going by 200 thinking of poppers? Oh, okay. So we're just gonna go down 1 tick mark over 1 tick mark. We can technically go down 1200 and over 1200. 2, 4, 6, 8, 10, 12. Oh. You want to just do that? That sounds easier. So down 1200, over 1200. There's our 1200, and we can connect with solid. True? Are we shading below or above? Yeah. But we're only doing the first quadrant, right? Okay, so let's not stress. Below. Okay, who's next? This guy. Wait, where's his intercept? 0, 0, because I don't see a B, right? 1/2. So go up 2 over 400, right? Can I do that? Go up 2 more 100, go over 400. Go up 200, over 400. Solid, right? Solid. Shade above or below? So far I'm here, right? That's my overlap. I could shade more, but whatever, I'm just narrowing down. And then my last one. Okay. Negative 200. Here he is. 1/3. Go up 1, over 1, 2, 3. Go up 1, over 1, 2, 3. That's not very pretty. Above or below? You guys see my final region? So what are my vertices? precisely. Which means, I think we have the points, double check if I'm wrong. I think we have 0, 0, 600, 0. 600, 200, right? This one's not the one? 600, 200. We have that guy, we have that guy, we have that guy. Who's this guy? Ooh, I think there's a little off on him. 1, 1, 2, 3. Plus 1, 2. This one looks weird. That's the 600, 200, isn't it? Oh, it's not a vertex. Oh, so we didn't even need him. Lame. Okay, forget him. He's on the region, but he's not an edge, right? No. Okay. Who's another edge then? This guy's an edge. And that would be 1, 2, 4, 6, 8, 10. 10, 400. We have 1200, 0. Who's that other guy? I think the way we graphed him is a little tricky to see. 2, 4, 6, 8, 10. If worst comes to worst, kiddos, can't we go ahead and take green and blue? 2, 4, 6, 8, 10. Oh, it's up to it. Oh, you're on this one. Are you on that one?
Yeah.
Okay. He's one I haven't gotten yet. So this guy should be here. So who's that guy? Oh, I sketched him funny. Should he be up here somewhere? Okay. Now, as we were looking at, my graph got a little off. Some of you guys were being a little bit more precise. Question, how could we make sure? Couldn't we do green and blue? Couldn't we take green and blue? Couldn't we take, the 0, 0 was pretty obvious. We had him kind of from the get-go. And then we could take green and pink. If your graphs got off like mine. We have 0, 0, we have 600, 0. Those are the intercepts. We had 2 more over here that we were trying to figure out. My graph got off because I was using little baby tip parts. We could go ahead and, remember, treat this like a system of equations. Negative x plus 1200. Y equals 1/2 x. And we could solve by plugging in. And we could end up with something like 1/2 x multiplied by 2, x equals multiplied by 2, negative 2x. And then we have 2400. 3x equals 800. Plug in. Y is 400, and that's what some of you guys got because you got good graphs, right? So we could have taken that. We would have gone ahead and found y is equal to half of that. For green and pink, we could have gone ahead and taken those 2 equations. Y equals negative x plus 1200. Pink would have been y equals 1/3 x minus 200. We could have done like an elimination-y thing, just to be easy. 0 equals negative 4/3 x plus 1400. Long story short, x would end up equaling but I think I did, right? Yeah, I think I did. So then you would get 4/3 x equals 1400 multiplied by 3/4 multiplied by 3/4. Does 4 go to 1400? 350 times and 350 times 3. That's it, 3 and 2. What would that end up equaling? Nope, 200 plus 1200, right? So 1400. So the last one would be 1050. Should we plug back in for y? I think that'd be 150, right? I'm plugging into this one right here. See how he's a little bit fast. The graph is really precise. So this is where we have to be a little bit more, because some of you guys might have rounded to 1,000, but it was actually 1,050. Okay? So, some of them you can get directly from your graph, and some of them are going to be a little bit off. Mine was a little bit more off than some of your guys's. However, I was still on the same track of, struggle. It wasn't 1,000 evenly, it was a little bit past. But now that we used our math, we used intersections with our systems of equations, now we're able to say, hey, these are the vertices. Let's go ahead and test them in our profit equation, right? Has anybody already started plugging and chugging? If you have 0, 0, isn't your profit going to be 0? That's not good. If you have 600, 0, what's your profit? If you have 800, 400. Some of you guys are wondering, what was the profit equation again? It was 150 times x, right? Plus $2 times y. Has anybody plugged in 800 and 400? 2,000? How about 1,050 and 150? What was it? 2,750. Okay, Brandon was finding those for us. Was anybody plugging and chugging?
Wouldn't the 600 be 900?
Yes. Almost. We just got off on one of them. Good. That's what I double check. This one was 2,000. Yeah, I'm pretty sure it's 12,000 or 2,000. So then, where would our maximum be? Oh my goodness, that's way off. No, it's not off. It's true. So your maximum profit, which they were asking for first, is going to be of how much money? When. We could say at. We'll say when instead. When we sell. Is that what's going on? Oh, produce. When we produce. Which one came first? Did anybody check the very bottom one?
Anyone got 18 something?
Yep. There we go. We caught up. Something went funny. But is that still? Oh, that's not the highest anymore, is it? So what's the highest instead? So be careful when plugging into calculator, but thank you all of my people that were participating. Because that's what we need to double check, right? So we're going to go ahead and instead choose this again. We're going to say maximum profit of $2,000 when producing 800 boxes of creams, chocolate covered creams that is, and 400 boxes of chocolate covered nuts that is. Dun 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 dun. You guys see what I did another day on section 7.6? 6? Is it impossible? No, but does it put a lot of math together?
Yeah.
Yes. Can you just trust your graphs?
No.
Woo! So if worst comes to worst, where are we going? Systems of equations. You're graphing on your calculator, party numbers. I suppose so. If you're plugging in, you could do that as well. Hey, we're done. Anybody still needs to take a picture of the review if you want to start it tonight, or if you got some work done on 7-6, there it is. But otherwise, finish 7-6. Tomorrow review. Friday test, except for yeah, Milani. Must be calculus then. Angela, Ella, Brendan, somebody. Try to figure it out.
The dark of the comma.